Okay, this visual effect is quite satisfying to watch, really. But what you're really seeing, it's a point moving through space, um, a grid, really, with scattered, with static scattered points on it. And what we are going to do is to make connections with those static scattered points based on a threshold distance. And that's basically it. The only thing left to do after that is to change the length of these lines based on the distance between the moving point and the static points. And we're going to do that using the parametric positions of the line. And as I said before, we're going to drive that distance based on drive that length, using the distance between the points. And that's basically it. There's a little bit of noise applied afterwards, but yeah, the essence of the effect is this one. In a new Houdini session and inside a geometry node, let's drop down a grid. And we're going to scatter points. Scatter. And we're going to save some attributes on those points. We're going to say we are going to create an rest position attribute and an ID attribute. ID is going to be num plus 1 pt num. And we add rest pos is going to be equal to add p. Okay. Over these points, we're going to copy circles. Copy 2 points. No. Points underneath the circle. Copy the circles onto these points. Let's change the orientation and the scale. They're too big still. Something like this. Okay. I'm going to scatter more points because I want each leg to have a lot of sub legs or something like that. So let's scatter more points. Yeah, something like that. I want another ID attribute. So plus 1. And I need an outwards vector from the center of the circle outwards, right? So this is why I saved this rest position. And let's call it there. Normalize. Normalize at p minus v at rest pos. Let's visualize this attribute. Okay. Here. Let's make. Okay. As you can see, we have this dir attribute is a vector pointing outwards of the circle. Okay. Let's create the moving point. We can add. Let's visualize this. There it is. I'm going to template this. It's a transform node. Transform node. here. And now I'm going to animate this with another transform. And create this negative other side and the old and trusted $F multiplied by 0.02 maybe. Let's see. Oh, $F. Yep. Oh, that's kind of slow, but let's try it like that. I also want to elevate this point a bit, so let's do it here. Something like that will do. And I also want to displace the path of this point. So for that I'm going to use an attribute verb. Here we're going to use an anti-alias flow noise. And we're going to drive it using the position, and I'm going to promote these parameters. And I want to avoid displacing this point on the Y component of the position. So let's drop down a vector to float and a float to vector. Let's wire this as they are, but for the Y component I need a parameter, and we're going to multiply this Y component by a parameter and wire this here. Now I need an add to add my current position to this displaced position, and we have to change this type of noise to a 3D noise, of course, and just then output this here. Okay, let's go up and let's play to see what is going on. Okay, that's nice, but as you can see, no, it's kind of nice. It is moving in the Y direction. Why? Let me see. 3. Okay, why is that? 1. Oh, well, I know why. What a dumb thing to do. Okay, let's connect this one here, and no, this should work. Yes, like that is perfect. Maybe a little bit more amplitude. Let's higher up a little bit the frequency. That's too much. No, only the amplitude. Like that is okay. So let's connect the static point with this animated point. So for that we're going to use an attribute wrangle. Let's wire this in the first input and the scattered points on the second input. Okay. Okay, we're going to need a radius, radii, rad, shell float, and amount of flex that we're going to create. And this parameter is going to drive the amount of points to look for in the near points position. So it's an integer, so x. Okay, we're going to leave that like this for now. Oh, I know what else. The length of the feet. So you will see. It's going to be a float, length, general float, fit, length. Okay. Now I need to get those nearby points. So and BTS array is going to be equal to near points. The input number 1, we're going to drive it by P, by our position. We're going to use this radius, and we're going to find this amount of legs. Okay, let's change this a little bit, something like this. Okay. So for now, let's use a radius of 1. And maybe, I don't know, 200 legs? Something like that. Now, we are going to iterate all over this array to create the lines. So, for each 2 point PTS. First, I'm going to get the position of this point, so it's going to be vector pass equals point going to be on PT. That's correct. No, I want this ID. I want this ID 2 that we have there. So let's get it. And ID 2 to be ID 2. This point number. Okay. I need the direction too, so vector there, point 1, t. So I'm not going to create a straight line. I want to create sections so we can like sort of shape the leg. So for now I'm going to create a point at the position that we found. So let's say int pt, let's call it new pt, it's going to be equal to at point function 0 on this boss. As you can see, we created all of those new points. But I want to create a joint. And this joint, let's create the position of the joint point. Vector a boss is going to be equal to set, and we're going to use the same x and z position of the new point, but it's going to be displaced onto y. So well, let's do that. I'm going to say boss.x into, I don't know, maybe 0.5, let's see, and boss.z. Let's create this new point, int j point is going to be equal to point j Okay, 0.1, 0.55 is too much. Oh, maybe we can do the following. We can use this at p dot y and multiply it by 0.7 maybe. Oh, that's way better. And we need an additional position that is going to be the tip of the feet. It's going to be a vector. This is going to be tip pos. It's going to be equal to. Okay, to create that, we're going to need to displace this position by the direction attribute. So let's do that first. And for that, we're going to use this length variable that we created here. I'm going to say this is going to be equal to pos plus dir multiplied by length. That's all there is to it. And let's create this new point, int. Let's say the t point. To at point 0 on t pos. Okay, let's see. Let's move this fit length. There you go. Very nice. Now I want to create a polyline between all of these points. And prim equal to at prim. So it's going to be a polyline, and it's going to be at pt num, include at pt num. Now I need my joint point, then my new point, and the t point. Oh, look at this. Quite nice. Quite nice. Okay, I'm going to reduce this diameter. It's too much. Something like this. Yes, I like this better. And if I press play, let's disable the point visualization, and let's extend a little bit those legs. There you go. Okay, this is the basic layout of this effect. Now I want to transfer some attributes to these points. So let's do that. But before, I want to see one thing, so resample. Let's visualize this point. Maybe something like this. And we're going to say that we're going to resample and by subdivision curves. I want to create a crease here because I don't like how this looks like. So let's create some attributes before. I'm going to bevel this this point right here, and for that I'm going to create an attribute. Okay. I also want to transfer this ID2 attribute to the points. Okay, let's do that. That point attribute geometry number 0. The attribute is going to be the name 2 bevel. That was the new point, right? Yeah. Point 1 set. I also want, now that I remember, the original ID attribute, of course. Point 1 ID. ID. But I'm going to place those attributes on this primitive. Set prim attribute. To be ID. Set, oh, not one, but ID. Let's copy this guy to set the ID to attribute. Attribute ID to attribute. Okay. Now, before we create this resample, let's bevel. Add to bevel equals 1. This is a point. This is a point. Let's see. Look at that. Yeah, that's basically what I wanted. Now we're going to create the interpolation that drives the animation. So. Yeah, oh, I'm forgetting something very important. And it's to create a distance attribute between our animated points and the found points. So let's do that, and that is going to be the following. The float is going to be called dist, and it's equal to @p minus bus, and that's all. Of course, the length. Bus. That's it, and we're going to where on the primitives. So Control C, Control V. We're going to call this list on the primitive and list. All right.